Hello everyone. Today we're going to finish section 4.4 on page 254 in your online textbook. We're going to be graphing logs today. So you will definitely need graph paper for this lesson if you want to be more neat about it. So I'm going to take an example. I'm going to start with an example. Y equals log base of 3 to the x. So the first, brief rain alert. No, I don't know what I just did. Okay, we're back. So the first thing you want to do when you have an equation is taking what you know from the previous videos is it's helpful to write the y on the other side because we're going to be applying the snail. Reason is, with the equation we have right now in log form, it's going to be difficult to graph it, and you'll see why in a second. So let's apply the snail. R3, we go around, we come back around like a snail, so that would be 3 to the y power equals x. So this is what we're going to be using to make a graph. All right, now we're going to make a table of values like we always do when we make graphs. The hardest part about this is usually what we do, and you're used to doing, is that we plug in for x, but not for logs. Okay, so what we're going to be doing is we're going to be plugging in for y. Why, you may ask? Well, because if you look at the equation, it says 3 to the y power. So y is our input in this situation. So we're going to use -2, -1, 0, 1, and 2 as we usually do, but it's weird because it's backwards. It's into the y's. Okay, now we're going to find our x values. So 3 to the -2 power, what does that equal? If you learn from anything from the previous lesson, you know we have to flip the base in order to make that 2 positive, and that would be 1/3 squared, which is 1/9. And if you want, you can write that as a decimal. It's approximately 0.1. It's repeated 0.1, so we're just going to say 0.1 because when we graph, we need to know where to plot that. Okay, and now we're going to fill in the rest. Pause the video and see if you could do it yourself. And now that you're back, you should see that you get 1/3 or 0.3 repeated. 1, 3, and 9. All right, and now we just got to make this into a graph. And also we do have to state our domain and range. Let's do domain and range right away before we even go into the graph. So if you remember from exponential graphs from before, from exponential growth and decay, our domain was always all real numbers. And that's because we plug in x. But now, since we're plugging in y, now the range is all real numbers. Okay, whereas before it used to be domain. And now our domain is what is, if you look, the numbers are all greater than what? They're all greater than 0. Okay, they're not equal, they can't be ever equal to 0, but they're all greater than 0. And now we're going to make a graph. So let's make a graph. I'm going to use my ruler. So I've noticed my graphs in my other videos are so messy. So I'm trying to be neater about it. All right. See, this is why I can't be neat. I'm just going to have to go with this. It's taking too long. I'm sure you're thinking that. Okay, so let's sketch that. So 1/9 -2, where is that? That's 1/9 on the x, which would be like somewhere around here, and then -2. So there. 1/3 on the x is like a little bit further, so let's just say there at -1. Then 1, 0, we know where that is. 3, 1. 3, 1 is right here. And then 9, -2. 9 is going to be further out. So this is 3, 4, 5, 6, 7, 8, 9, and then 9, 2. And now we connect, and we are done. Okay, so if you were to turn your screen or just turn your head to the right, you should notice whereas the J curve that we used to do before, or the L curve, it's the opposite pretty much. These equations are the inverses of our graphs from before. If you turn your head, you see that L, right? All right, you're going to try one on your own now. It's going to be on page 255, number 16. I know you probably don't have your textbook in front of you, so I'll write the question for you. You're going to pause the video and see if you could do it yourself. All right, so go ahead. Try this problem. You're going to graph, state the domain and range. All right, now that you are back, let's see how you did. I did this problem ahead of time so I could save some time on the video. So the first thing you should have done was rewritten the equation. It's using the snail method. You want to create a table of values, but plugging in for y. Those are the values you should have gotten. Now, because our x value one of our x values goes all the way to 25, if you look at my graph that I made, on the x's I skipped by 5s. And so there it is. There's the answer to the problem you should have just attempted. All right, I'm going to do one last one for today, and this is pretty much the end of the lesson. Okay, so I'm going to have to start a new page here. For some reason, it doesn't want to scroll. Having a lot of difficulties in this video for some reason. All right. Okay, I don't know why I can't access my graph paper. So, hold on. I can do this. All right, perfect. All right, so now let's take a look at this last problem. So here's a problem. This is the hardest it gets. Here's a problem with extra numbers here. Okay, so if you remember from a previous lesson, when we have extra numbers, we want to kind of just ignore them because those numbers are going to be our numbers we're going to use to shift. So for now, you just basically want to take this and graph it the same way you just learned. So start by, we'll change this f of x to y. And we're going to rewrite the equation as you learned before. So that would be 4 to the y equals x. You're going to make your table of values. And I'm going a little quicker now because you kind of already know what's going to happen here from the previous examples. All right, so here it is. So again, step 1, do exactly what we just did before, right? Just using the beginning of the equation. Now what we're going to do is we're going to take these numbers and we're going to do the shifts. So if you remember from before, the number that's next to the x, you always take the opposite sign and do that to your x values. And then this number is always going to stay the same. And you're going to do that to your y values. So that plus 1, we're going to do minus 1 to all of these. And then that minus 2 is going to stay the same. And you're going to do that to your y's. That's going to give you your new table of values. And that's going to help you create a new a graph. Okay, so here we go. So I'm going to do 1 over 16 minus 1, and I'm going to use a calculator here. That's going to give me about negative 9.4. 1/4 minus 1 is negative 0.75. 1 minus 1 is 0. 4 minus 1 is 3. 16 minus 1 is 15. And then do the same to the y's. So that would be negative 4, negative 3, negative 2, negative 1, and 0. So our range is still going to be all real numbers, okay? So always for range, it's going to be all real numbers. Our domain, however, is not greater than 0. If you look at these numbers here, they're not greater than 0, right? They're less than 0. So for your domain, you always want to do greater than whatever the shift was, so greater than negative 1. So all of these numbers here are always going to be greater than whatever your shift was. All right, so x is greater than negative 1. And that's pretty much it. Then you would just plot these numbers and you would create your graph. And I'm hoping you can do that on your own. All right, hope you guys understood the video. Take care.